All right, welcome in everyone. We will just give about a minute or two for people to start joining. All right, I think we can go ahead and get started. I do see people still joining, so I'm going to start at the 2 minutes past the hour. So we'll start in a minute here. Hello, thanks for joining. Appreciate it. So we have someone joining from Twitch. Awesome, love to see that. I guess I should say good morning, good evening, good afternoon. I know that we have viewers coming in from everywhere. Okay, it is 8:02. I am going to go ahead and get started. Thank you, everyone. Thanks for joining. If you're still funneling in, no problem. We just started. So we have some people coming in, leaving comments. All right, let's get to it. So today we have a really exciting chat with the experts set up for you guys today, a conversation, if you will. We're going to be talking about Kafka, everything Kafka. So I wanted to just introduce your speakers today. The panel, we have Filip Yonov. He is the head of cloud data streaming, and then at Aiven. And then we also have Josep Prat. He is the Senior Engineering Director of Streaming Services at Aiven. And then we have Purnima Kumari. She's the Senior Solutions Architect at DigitalOcean. I myself am at DigitalOcean as well, and I will be leading today's call. So we're very excited. And let's go ahead and get started without further ado. Okay, so we have a chock full call for you guys today. We're going to go over DigitalOcean for any of you who are brand new. And then we're going to go over Kafka, and then we'll open the floor to our Q&A session. You guys are welcome to ask questions as well. So please post your questions in the comment. I will lead and direct the Q&A. And then we'll talk about our managed Kafka offering, DigitalOcean's managed Kafka offering after that. And then we'll just talk about how you can get started. So what you'll gain from this session, you're going to learn more about Kafka, understand the real-time element of it, the real-time data streaming. We'll talk about use cases. Again, we have two experts here, so you'll discuss that with them. We'll just talk about how you can accelerate your delivery, your product delivery, your go-to-market delivery, and reduce operations overhead with Kafka. And then we'll talk about DigitalOcean's offering. So now to the fun stuff. I'll hand it over to Purnima.
Thanks, Nicole, for setting up the stage and providing the agenda for today's webinar. So now moving forward, to start the things right now, I would like to give a quick introduction about DigitalOcean for those who may be new to the platform. So DigitalOcean is a cloud computing platform designed specifically for the developers and startups and the enterprise, keeping in mind. It enables you to build, deploy, and scale application quickly and easier, all without worrying about the complexities of the traditional cloud provider. From, I will say, we provide you virtual machine called droplets to manage database and fully managed Kubernetes service. So DO offers you a cost-effective and performance-optimized solution, and while keeping simplicity developer experience in the mind. Most hypervisor or most of the hyperscalers cloud is, while powerful, however, they are not right fit for the digital native enterprises. When I say this, because it tends to be more complex, right? Come with a steep learning curves and often carry hidden costs that can quickly spiral On top of that, there may be lock-in into a long-term contract that do not always provide the hands-on responsive support that growing teams actually, what your team will actually need. And this is where DigitalOcean will offer you a refreshing alternatives with simplicity, transparency, and developer first cloud for all. Now in the next slide, I will be discussing about the purpose built for digital native enterprise. So at DigitalOcean, we are purposely built to provide a need of the digital native enterprise. When I say this, why? The reason behind this is you're operating lean with the team, right? You don't have armies of DevOps, Cloud Ops, or even the FinOps specialist with you. It might happen, right? Because you are a startup company. So you need a cloud that is simple to manage across its entire life cycle, not only that demands a lot of overhead just to keep the lights on. That's where we come into the picture, because DigitalOcean delivers simple, full-fledged cloud that's easier to scale as your needs grow, and all backed up with the enterprise level uh, SLA to support your mission critical products what we provide. And we are also a trusted partner for you. We will give you a transparent, predictable cost, 24 by 7 support when you need it, and a freedom to use an open ecosystem that grows with you. So in short, if I tell you, have a scalable, simple, and approachable cloud, and that's the DigitalOcean difference from the other hyperscalers. Now in the next slide, I will be talking about how we empower customers around the globe. So at DigitalOcean, we provide robust infrastructure and a reliable network connectivity to business around the globe. We have 16 distributed data center, as you can see in the slide, in 9 different regions with 638K customers, 1,665K digital native enterprises, and more than 3 million active developers. We are going to launch a data center in Atlanta. Also, DigitalOcean data centers are certified to meet a top security compliances and sustainability standards to protect your data and ensure the trust of the users of DigitalOcean. Now in the next slide, I will quickly tell you about the different cloud services that you will get on DigitalOcean, starting from the SaaS, or maybe starting with the infrastructure as a service offering, where we provide you virtual machine storage, networking solution like load balancer, object storage is there for your storage purpose, block storage is there, and also we provide you a pass offering, which recently we have launched Gen AI platform, and also we have app platform which enables the users like you to build and deploy managed Kubernetes application, right? And apart from that, we offer a cloud web hosting solutions for you. Finally, let's talk about the software as a service offering. So we do provide an AI agent and third party applications available through our marketplace. So now I have talked about DigitalOcean. Now I will take a deeper dive, or I will talk about the Apache Kafka, because today's topic is more about the Kafka. So now in the next slide, I will be talking about the introduction of Apache Kafka. So Apache Kafka is a open source distributed event streaming platform designed basically to handle a real time that the data that is fed, and also being a real time data pipelines and streaming application. It also help you basically to handle, or it is designed in a way to handle a large volumes of data with low latency, and is highly reliable, and fault tolerance is also there. So let me just quickly cover about the architecture of uh, Kafka, what all components are there. Like producer is there, which publish the data. Topics is there, where the data is stored. Consumers, which read the data. Brokers are there, which is basically a server, and Zookeeper for the coordination. And some of the quick use cases I have listed down here, like collecting a logs from distributed system, embedding a real-time processing, or decoupling service using different communication processes. So now let me talk about why to choose Apache Kafka. So the reason here is There are a couple of you can see listed features which is provided by Kafka. So one of the key strength is high throughput with low latency. It means it makes you it is more suitable for high volume and data pipelines workload. And Kafka is also distributed and a scalable architecture that allows you to grow with your business, because you will be growing, right? So we want your business to grow, and Kafka is going to help you out there. You can add more broker as your data load increases eventually. And it also ensures a fault tolerance and durability by replicating data across different multiple nodes, ensuring nothing is lost even a server goes down. And also Kafka is good for a real time processing, right? That is one of the most common use cases, and where it will help you to enable this applications like fraud detection, monitoring, dynamic pricing that rely on the live data that is being fetched by the Kafka. Also, it decouples the producer and consumer, meaning system can evolve independently and without breaking the pipeline what you are having. So in short, I can say Kafka is a rich ecosystem, and it has a strong integration and support with your flexible choices that fits into various architectures and tools. It can get integrated with tools like Spark, Hadoop is there, databases and cloud providers, different like DigitalOcean, and making it like more robust and flexible data backbone, right? So now I will just quickly cover about some of the real world use cases. Uh, the first one is about analytics, which is a real time data pipeline. So let's take an example here. It's a there is a marketing platform ingest and click stream data to Kafka for live behavioral analysis, enabling dynamics, ad placement or user engagement tracking purpose. In fintech also, it's being used for fraud detection, transaction processing. So if I take an example for a fintech, let's have a payment gateway which is streaming millions of transactions into Kafka to power a real time, I will say, fraud detection will be done in this case, because they will have an algorithm for that, and that will make sure there is an instant validation with low latency for you guys. Now the next use case is about the IoT, where streaming uh, data comes into the picture. So logistic firms stream live data from sensor like delivery trucks. They like measure a couple of things like temperature, speed, GPUs, and these informations are given back to the Kafka for real-time analytics and route optimization. So IoT business can also make use of this. Real time retail comes into the picture. So in retail case, I've seen customers using it for personalized offers in a real time. So when I say this, say you are having an e-commerce platform where users comes start browsing your e-commerce website, and there's a cart that is having a data and giving those data, whatever is being added by the customer to the Kafka, to have a delivery of a real-time recommendation, discounts, or even I will say AI based engines will come into the picture and help in this retail use cases. Now the last one, what I'm going to discuss today, is about the gaming. There are lots of more example, but I have just taken 5 examples here to relate so that most of the people can relate here. So let's talk about the gaming use case. So it will help you to provide a real-time leaderboard, because when we go ahead and play any game, there is a leaderboard. So there Kafka comes into the picture and help you out. Having a matchmaking can comes into the picture. Say there is an online multiplayer games which feed player scores and match stats into a Kafka to update the leaderboard and enable skill based matching in real time. So these are the use cases which I wanted to discuss today. In the coming slides, we will be having a Q&A with the experts, and we will discuss more about the use cases, and yeah, we will discuss on those things further.
Okay. Thank you, Purnima. Appreciate that. So if you have a question, feel free to put it in the chat, and then I will um, upload it onto the screen so everyone can see it, and then we will have our experts answer it. Simple as that. Purnima, I believe you did have some questions you wanted to ask them, so let's just go ahead and get started with that.
Yeah, of course. Guys, right now I have a couple of questions which I wanted to discuss with Flip and Joseph about. So the very first thing I want to understand, how does a Kafka is different from a traditional messaging, because we see lots of customers using different messaging systems like RabbitMQ, ActiveMQ, and customer gets confused there. Why to use Kafka? Why not to go ahead with RabbitMQ? So if you get some insights on that, that will be really great.
Yeah, that's great. First of all, thank you for having us. I'm really happy to be here and talk about Kafka. So let's get straight to business when it comes to Kafka versus MQ. This is one of the most popular questions we often get from our own customers, from people who are kind of transitioning out of MQ into Kafka and vice versa. I think you already explained it very nicely what Kafka does and why Kafka is so good, right? We have the partitioning model, we actually use persistence, etc. The thing about Kafka is that most of the motivation when Kafka was created was actually to overcome the traditional messaging queues limitations. And the real limitation was not coming because the MQs were broken or the architecture was kind of like wrong. It was because they couldn't handle the big data when it comes to, for example, from click streams, from all sorts of log aggregation, metric aggregation, etc. It just couldn't handle it because most MQs, if not all, are basically designed around memory. So the moment you actually blast them with gigabyte per second scale, they just cannot handle it. So if we really look at kind of like a simplified comparison, think of Kafka as this single append-only runway that keeps every record in order until the end of time, right? From time zero to time to end of the time. While traditional MQ, let's say RabbitMQ or ActiveMQ, one of the most popular out there, is that basically this MQ system will have multiple shorter runways. Like each of them can kind of have its own purpose. It can have a small landing pad, and more importantly, the moment actually the event is acknowledged in MQ, it's gone, right? One of the key differences with Kafka is that Kafka actually persists data, and this is tunable, so you can persist data for a very short time, or you can persist data for extremely long time, or maybe infinite, especially with the new cloud primitives. The other difference here is that messaging queues exist for much longer than Kafka itself. I think that's probably 30 to 40 years. Correct me if I'm wrong. And anybody in the chat, if they know, probably they can say. But it's for a very long time. We already have messaging queue acting actually as a middleware for large enterprise setups, and they are extremely good when it comes to their exactly once semantics and overall at least once semantics. Whereas Kafka is really designed around big data ingestion, and only afterwards we started getting at least once and exactly once and all sorts of other kind of setups which can kind of carry over some of the messaging queue capabilities. So it's really if we want to abstract away the answer here, think of your kind of Kafka as a data DVR for your business events. Everything shows in order. Let's any number of views to start, pause, replay independently per topic. It keeps the recording safe across several servers, right? So it's massively distributed, very, very safe. Whereas classic MQs are more like a walkie-talkie, right? You basically it's very good for very quick and one and done kind of delivery between two parties, but they don't keep a library of past conversations. They don't keep the history.
Yeah, I think I'm able to relate about lots of things, because when we go ahead and suggest to customers, we tell these things to the customer. But yeah, for the larger audience, I believe this is
Yeah.
good what you have told. So there is a question by.
Mhm.
Do you want me to handle that?
Yeah, go ahead, Purnima. Looks like we're getting a couple of questions in, so just letting our speakers know, I will be putting them up. If you see them blown up like this, then that's yours to answer. So looks like we have a question from LinkedIn. Does DigitalOcean offer a managed streaming service for Kafka data processing like Flink, or any plans to introduce? Purnima, I think you can take this one.
Yeah, of course. So hi, Mehul, thanks for the question. So of course, we do have a managed Kafka offering, and I will be discussing about that once the Q&A is done. I will be discussing and tell you about what are the offerings we provide in our managed Kafka. So yes, we do have managed Kafka offering.
All right, another question. Can or should we use a product like DigitalOcean Spaces to store the data as we receive it? Can or should object storage be used to hold the data being placed into the system? Or is this a poor financial choice versus just using attached drives? I'll let the speakers on the panel decide who wants to take it.
I can take that one as well if you want. So there is a feature on Apache Kafka called tiered storage, which goes more or less to where the Aaron is asking, I'm guessing. Tiered storage is for the times where you have a big retention time. So we said before that Kafka retains data for a specific set of time that you can configure and define, but the accessibility of this data, it's different. You might want to keep let's say 2 weeks of data, but you rarely access data that is older than 3 days or 1 day. One economically sensible thing to do is actually opposite of what the person asking the question hints at, is actually a good economical decision to do is activate tiered storage in Apache Kafka, and every single data that is not on the active segment is being uploaded to the remote storage, so to the object storage, in this case, DigitalOcean Spaces. And the idea is you have now 2 different deadlines where data is being deleted or moved around. You have the local retention period, which is when data is staying in the local disk. And from that point in time, data only resides in the remote object storage. That obviously means that you have a better savings because disk space is way more expensive than object storage space. So that's a really great way to save money if you want to have a longer retention period, but your accessing patterns on data are skewed towards the present time. Obviously, when accessing data that is on the object storage, you will pay a light penalty on accessing a remote storage, but that's something that you can obviously assume because it's only happening rarely.
Okay. Thanks for that question, Aaron. That was a good one. I see we have something here, and I apologize, you guys. It looks like the questions are blocking some of our speakers. I'm not sure. So let me see if, maybe when I remove myself, that will show Josep's beautiful face. But Guru, it looks like you had a question. Did you want to just ask generally about scalability and stability of Kafka? I'll let the experts.
Yeah, I'll take this one very quickly because this can be a very long topic, and I will provide kind of like a very high level on this. Actually, Kafka is often chosen exactly for the durability, scalability, and overall performance of the software. As I already mentioned, it is conceived to handle big data. The very first principles of Kafka are that it will actually work and be happy at gigabyte per second scale if it needs to, right? Simply because a lot of design choices were made intentionally not to have, for example, bottlenecks when it comes to, like handling the data, storing the data, replaying the data, and all other things. Of course, like handling upgrades, handling scaling up. It's not that great at scaling down at speed, but at the same time, in all the right kind of like directions, when you actually want to handle increasing amounts of data, Kafka provides pretty good curve when it comes to cost versus performance. Josep later will talk about how this curve is actually being kind of skewed in certain hyperscalers and what we're doing right at Aiven to fix it. But long story short is that it's pretty good and high quality software when it comes to, for the purposes it was originally built for.
Okay. Thank you. No, that's a good topic to talk about, scalability and stability. I'm going in chronological order of how we get the questions. So it looks like Vishal from YouTube has a question. How do you monitor Kafka clusters effectively? Talking about tools, metrics, and alerts.
I can talk about DigitalOcean managed Kafka offering. Maybe later, if you guys want to add some generic or some other tools, please add in. So if you go ahead and make use of a managed Kafka offering of DigitalOcean, we do provide a cluster metrics and alerting system to you. So when we say we provide a cluster metrics, so you will get a visualization that will help you to monitor the performance of the nodes of the Kafka database cluster, where you can see a couple of things like resource utilization, and which will help you to guide with the capacity planning and optimization. And coming to the alert part, yes, we do have an alert policy where you can set up, and which will notify you when any metrics rises above or fall below a threshold, but that has been set from your end. And it can be high CPU or low memory. So we do have these offerings from the DigitalOcean side. I think, Vishal, I have answered your query. And if experts, you guys want to add any other suggestion for metrics, please go ahead. Yeah.
I think you cover it quite nicely. I mean, there are obviously plenty of open source tools as well that they are useful to hook into a Kafka cluster that can offer some visibility behind. But yeah, that's what I would say.
All right. So let's go ahead and address this. Looks like we have a follow-up question. Follow-up concluding, or yeah, follow-up question. Which one of you wants to take this? Pranima?
Yes, I can just give 2 cents here. So we don't offer Flick at the moment. However, there is other different mechanism to work around with the data or to move it to some another system. So maybe make use of Kafka connector there. And to PostgreSQL, we have a database offering for PostgreSQL, so you can make use of that. Or maybe you can use some another Kafka offerings, Kafka Stream, so that should help you here. But yeah, Mehul, your feedback has been taken. I will of course make sure this has been given to the product team. Yeah, thanks for sharing that.
Yeah, I also just want to say that there are ways to give our engineering and our engineers who are working on our managed databases feedback. I can also include that in the end. But things like Kafka Connect and Kafka Schema Registry, we're aware and we're working towards it. So just want to let you guys know. Okay. I will go ahead and put the next question up. From Pravin from LinkedIn, AWS just launched a native Kubernetes dashboard to improve cluster observability. Does DigitalOcean have any similar plans to enhance Kubernetes cluster availability, like native workload viewers? This is a Kubernetes question, so I don't think we'll be taking that. I don't know, Pranima, what do you think?
I don't know. We also need to discuss this internally. Then only I will be able to comment anything on that.
Yeah.
But thank you for pointing that.
Pravin, we can connect with you after to help you get the answer to this question. I can work with you. I see that you have a LinkedIn account, so I can maybe connect with you on there. But yeah, I think that we'll need to follow up on this question, and we'll keep it to Kafka. We do have a lot of exciting things happening for Kubernetes, though, I will tell you that. Okay, another question from YouTube from Vishal. Can you explain your approach to data retention and compaction strategies for high throughput topics?
I can take this one because unfortunately or unfortunately, I have this conversation probably at least twice a week. Let's start with the retention. I always advocate for the industry standard of 3 days retention. Why 3 days, you ask? If something breaks on Friday, you will still have the weekend to come back to your data instead of getting expired in the broker and losing it forever. As Joseph said, with tier storage, this is no longer such a crazy consideration, right? We don't really need to have the disks as bottlenecks. So 3 or 7 days retention is always kind of like a good idea. Everything lower than this usually is for something which is not that important or kind of like is more in the command slash future looking event. So basically the moment the event is produced, it triggers something else downstream and you don't really need to persist the event too much. So that's on the retention. When it comes to kind of like configurations, right, and overall, practical tips, I would actually suggest also to really look at the cluster holistically. Start always with the cluster configuration, then the broker configuration, then the topic configuration, right? So the cluster has layers and the configurations kind of work together, but not only together, but also with your producer and consumer. So this is where, like many people get lost in the Kafka complexity. Like a specific configuration will impact the cluster, the broker, the topic, and the producer and consumer. So it's extremely fractal, kind of like problem within the problem within the problem space. So when we talk about retention, do you want to do compacted topics? Do you want to do compression, right, on the producer, for example? Do you want to do something specific with your ordering, for example? And do you want to kind of like glue your consumer group with your partitions or intentionally partition more just for ordering purposes? This is always needs to be looked at holistically. What do you want to achieve with this stream, for example, to begin with? There is no one answer fits all, but rather kind of like ask yourself the question first, what is this topic for? Is this actually workload good for Kafka? And we can get into this later, right? Where Kafka is good and where it isn't. But more importantly, ask yourself, what is the purpose of this topic? What actually data are we going to expect there? Do we need to version the stream, right? Meaning that do we need to use a schema registry? Do we need a schema? Is the data source going to continue evolving, for example, adding or removing fields? And is this going to break my downstream consumers? And last but not least, also ask yourself, what is the overall pattern here? Are you kind of like a fire and forget pattern where the producer just emits the data and some random listener is subscribed to consume? Or it's more of a command pattern where the producer message is expected by someone specifically downstream for a specific task to be executed upon receiving or ingesting this. So this is kind of like the discussions you need to have to understand like what works for you when it comes to retention, when it comes to partitioning, when it comes to compaction and all these other cool stuff.
Also to add in there, Kafka has a compaction strategy, which usually what you decide to do is compact the topic by deleting all the versions of the same key, if that makes any sense. When Kafka stores messages, there is a key, and you can decide to compact by that key. Compaction, however, is not supported with tiered storage. So if you want to use one, you cannot use the other, unfortunately. But that's another concept that you can use to minimize the amount of data that sits on the disk. If you are seeing the same key happening all over again and again in the stream, in the same topic, the same key is being updated, you can reduce the amount of space that occupies by enabling compacted topics. But again, in the era of having object storage supported, many people decided to move away from compacted topics and decide to use tiered storage because it's economically more sensible to do that.
That is interesting. That was a good question, Vishal. Thank you.
Mm-hmm.
I have a question I want to ask you guys. So I want to know, how do you see Kafka evolving or advancing within the next couple of months and years? So like short term and long term.
Maybe Joseph, you can take the short term to midterm, because this is
I can take the short term to.
We're working a lot on these things,
Yes, so I'm really happy to say that we are working actively and extensively on improving Kafka as we speak, so to say. One of the previous question was talking about what we do with high throughput workloads, right? One of the things that we want to do is, right now, we know that Kafka knows how to talk to object storage, because that's basically through tiered storage. So we wanted to go one step further and say, what if Kafka wouldn't need any disk at all and would directly speak the new primitive that the cloud offers, which is object storage? Remember that Kafka was created before, without the cloud in mind. It was created with disks and machines and bare metal in mind. And everything around Kafka revolves around writing to disk, basically. You can see references to disk and page cache in the broker, for example, which is the main server of Kafka. And what we decided to try and see if it could be done, and actually it can be done, and it offers really great results, is to bypass completely writing to a disk and avoid having the replication overhead. What happens when you write a message into Kafka? Kafka needs to make sure that the message is durable, that it's persisted and it stays there in case of catastrophes happening. What you usually do is, when you deploy a Kafka cluster, you deploy a Kafka cluster with 3 brokers, which means basically 3 nodes of Kafka that they are running concurrently. When you send the message, usually, traditionally, you want to have a replication factor of 3, which means that every single message that comes in is replicated to 2 other brokers. Ideally, these 2 other brokers are in different locations. So in case of a natural emergency happening, like floods, fire, or earthquakes, your whole data doesn't go down, because the data that went into that single node coming in is replicated into other ones. When one node goes down, the other ones decide who is now the leader. And when a new leader is elected, we know for sure that it has the data, because we already shared that data. But that costs money, because we need to transfer this data along many different networks, and that's expensive. So that's what object storage do. Object storage has plenty of 9s on availability and durability of data. So why we need to pay that price twice as users of that service, right? We need to replicate the data locally to then push it to an object storage, and then pay again the same price for replicating that one. So we don't need to do that one. We can just delegate everything and delegate that durability of the messages to the object storage. And what we did basically is we created a proposal to Apache Kafka to enhance Apache Kafka and to improve it with something called diskless topics. And what diskless topics is, in a nutshell, is create a new type of topics. You can combine the classical topics you all know and love with this new type of topics, where data is being written directly to object storage. That obviously is useful for high throughput workloads, and when low latency is not a must-have. You can live with a slight delay. And we all have plenty of those ones, which is basically all the click ops workloads. We already have dashboards that aggregate data every 5 seconds. We don't need to pay the complete expensive real estate price of disks if we know that that's going to be replicated already in object storage. And if you want to know more about what that is, you can go to that KIP. KIP stands for Kafka Improvement Process. It's the number 1150. And as you can say there, it's called diskless topics. In there, it's being described exactly one of the things that we are working on. And obviously, I'm really excited about this evolution of Kafka, and how that's basically one of the things that we hope that it lands into Kafka in the near future.
Okay.
And Filip, you can take the longer term.
Yeah, I'll talk shortly about the long term. If we take your, like what you said, Joseph, there, and kind of like blow out those primitives into like, let's say, the next 5+ years, we are seeing already that Kafka evolves into this kind of thin layer of compute on top of object storage. Let's call it commodity storage, because object storage is just a piece of kind of like the storage puzzle in the cloud. My prediction here is that we will see far more innovation in the cloud, simply because we are forced to do a lot of innovation versus the data center. And I'll give you an example of what the world probably will look like. Up until now, we needed to kind of separate our clusters. Usually you would have a business cluster for the business critical events, which are low latency, but relatively low in volume usually. Then you have a high volume, but less business critical cluster. Say you call it, I don't know, logging cluster or metrics cluster, or whatever. And then you have your payments cluster or something else. In the future, if we really squint, and if this thin layer of compute is very elastic and it works with the same durable, plenty of nines kind of like object storage, which is also commodity based, probably these clusters will no longer be needed. Probably we will be seeing a cluster which will be serving different workload-based kind of like topics. The first step is already we are seeing it with diskless topics. So diskless is great for logging and metrics, right? So you can park and you can use in the same cluster those topics for kind of like economical usage of streaming data. But you can also keep using the classical Kafka topics, which are sub 100 milliseconds for business critical logic, without the need to spin on the second cluster. So it's one cluster which is kind of like serving multiple workload needs in a very elastic, very scalable, safe way. This is probably a future we all want, because at the end of the day, the core idea of Kafka to begin with was actually one event bus for a whole company, or one streaming API for the whole company on which you can actually build your streaming applications. So you really don't want actually multiple clusters to mirror stuff between them and keep them in sync. So once a source of truth, one cluster, one API for the whole organizational need.
Okay, thank you. No, that's great. So we have about 3 minutes left. Omer, I see your question. I just want to show it for transparency. I think that we will have to connect with you after. So if you want to connect with me on LinkedIn, you're more than welcome to. I can help you get your question answered just for the sake of time. Let me know in the chat if that sounds good. Purnima, I know you wanted to talk about DigitalOcean Managed Kafka, and I know that we had some questions about it. So go ahead and, just talk about it with this slide, and then I'll see if we had any particular questions about Managed Kafka.
Yeah, of course. Thanks, Nicole. I believe once I will cover this part, the other questions will be answered, which has been asked in the chat. So, guys, now, if any of the part, whatever we have discussed so far, has sparked any kind of curiosity in you, whether it's the power of event streaming or the real world scalability, or simply the idea of having a not go ahead and do a babysitting for the infrastructure whole day, then you are going to love what DigitalOcean Managed Kafka brings to the table. So the very first thing is about the transparent and all inclusive pricing. So there won't be any surprise billing, no confusing pricing tiers. You know exactly what you are going to paying for, and it's all bundled up. When I say bundled up, it means you are going to get a CPU, RAM, storage, everything as a bundle here. That means predictable cost will be there for your business, whether you are a startup or you are scaling your business there. And also one thing I want to highlight, in comparison to any other cloud provider, the pricing of our any product, it's a Kafka, Kubernetes, or any other product, the pricing is same across all the data center. So if you're paying the something for Singapore data center, if you're having a Kafka cluster in Singapore, the pricing will be same what you are hosting on the New York data center. So that is there. Second thing is, you can spin up a cluster in a minute. We know time is money for everyone. With DigitalOcean, you can launch a fully functional Kafka cluster in just few clicks. You can go ahead and have that without worrying about any complex configuration or endless setup guidance. Now, coming to the monitoring part, I believe I have already answered about that, but just quickly, I just want to touch on this once again. We do provide a monitoring and a alert policy system to you guys with the pricing what you are going to pay for our managed Kafka, so you can make use of that, and you can keep an eye on your system healthy without like having a dedicated Kafka admins, because we do provide that for you are. High performance without the pain. When I talk about this, Kafka is known for its speed. So Filip and Joseph also discussed about the same thing, right? So when we help you, and here DigitalOcean comes, and we will help you to unlock the power without usually having any headache of tuning or scaling the infrastructure. So we are going to take all the headaches of that, and you will be just focusing on running your application and having your data integration. Now, when we do provide you a managed Kafka, there is a enterprise grade security what we provide. So we provide you a encryption, accessible control, secured networking, so that your data is protected and compliance ready from day one itself. And also you will get a scalability option, so you can scale quickly from 1 GB to 10 TB. And as you grow, you can grow along with us without any pain. So I believe I have answered the other question also. So I think we should be good. And yeah, Nicole, I'm good with my
Okay.
slides.
Great. So you guys had a ton of questions, and I want to make sure, especially if you didn't get your question answered today, I think we had 2 people. I'll get you pointed to the right place. So the one on the right is the one for you. Have more questions, speak to our Kafka experts by filling out our contact sales form. I believe it was Omer had a question, and then Pravin had a question that we couldn't answer today, both coming in from LinkedIn. So you two, I would suggest scanning that QR code. I'll also connect with you on LinkedIn to make sure that we get you to the right place. And then the one in the middle. So if you are on another, or if you're working with another hyperscaler, if you're interested in a multi-cloud or hybrid cloud solution, and you want to migrate an app that has some Kafka infrastructure within it, we have a pretty robust migrations program set up. We will handle the migration for free until go live. We have a ton of MSPs, managed service providers, that can work with you, including Aquazeal, CTO AI, and they offer free assessments, TCO, cost analysis, etc. So if you're thinking about migrating, scan the middle one, and that will lead you to more information. And then the one on the left. So if you're brand new, you're not a DigitalOcean customer, you want to get started with Kafka, I thought I'd mention we offer $200 worth of cloud credits. So you can put that towards your first Kafka cluster. All right, I think that's it. I will leave this up just for a little bit, but that concludes our Q&A today. So I want to thank our 2 experts for coming on, Filip and Josep. Thank you very much. They're abroad, so it's, the evening time for them. So I appreciate your guys' time. And then Purnima, I want to thank you for your wonderful presentations. And yeah, thanks everyone. I appreciate it. Again, I'm just going to leave this up for a little bit longer to make sure everyone has a chance to go to the right place. So if you have any questions about the QR codes, let me know. But yeah, I think we should be good. So thank you, everyone. Thanks for joining. Appreciate it.
Thank you.
Bye.
Thanks all.
Bye.